Alright guys, so this is Fritzing, the program that we use to create wiring diagrams. In here you can also produce schematics and PCBs, which you might do later on in a engineering course. To start with, we just work in the breadboard section, which allows us to produce different wiring diagrams with kind of a three-dimensional view. Looks nice and pretty, but it can show basically how we're going to wire things up and demonstrate your knowledge and understanding of components and DC electronics. So on the right hand side you see we have a parts window and below that an inspector. And if neither of these pop up, all you need to do is click on the Windows button and you can make them appear and disappear. So sometimes you accidentally close them, you can make them appear again. So we're going to start with a breadboard. Now what we need is a half breadboard. So we can search for that and bring this one into our screen. And you'll see it looks just like the breadboard that you have in your hand or in your little kit. The next thing we are going to put in this is our Nano, which is the Arduino or the microcontroller that we're going to actually use to run all of our circuitry. And we can grab the Nano from here. Any of them are fine. I think these Rev 3 versions are a little bit better. Now if you right click a component, you get a rotate option, so I can rotate 90 degrees. And I'm actually going to place my Nano into my breadboard, just like you would do real life. So you can see now if I click on a point, you can see all of the points that are connected on that breadboard. Just drew a little Y there. And that way we can see, okay, well, digital pin 13 is also connected into A, B, and C of row 1. Or for example, the ground pin here, if I click that, is connected into row 14, A, B, and C, and you can also see it's grounded to the other ground on the other side of the Nano. So really handy to be able to see what components of ours are connected. So we're going to build a simple single LED circuit here, and we're going to do it in two different ways. So first thing we're going to need is an LED. So we can search for one of those. Then you have to wait for the searching to finish before you can drag it in. So you'll see this bar continue. And when it stops, we can click and drag an LED into our area here. Now we're going to plug this LED into these pins, and you can see now that those pins all become green, and if I hover over this one, they all light up yellow, and if I hover over this one, they all light up yellow. If you hover over the bottom of the pin, you see that we have an anode, and we have a cathode. That is because an LED, as you should know, is a polarized component, meaning that current will only travel through it in one direction. So the cathode is the negative leg and the anode is the positive leg. And you'll see that it has a flat side on the LED, much like when you look at an LED in real life. It has a flat side or a short leg that represents it is the negative side or the cathode. So the next thing we're going to need is a resistor, because we have a forward voltage on our LED, and therefore we need to resist down the 5 volts that comes out of the Arduino, so that we only have 3.3 volts running into our LED. So we can pull a resistor in, and we can run that in our circuit as well. Now I'm actually going to flip my LED so that when I put it into my circuit, my cathode is going through my resistor. You can see it lights up yellow, and that'll allow me then to run my resistor to ground. So one of the first and most important things to do with a circuit when you start to build it on a breadboard is that we usually connect our negative rails together. So I'm going to do that. I'm going to change the Y color to black or blue, it's up to you. And if I click along the wire, I can actually create bends in it. So I can take the wire off the breadboard, make it look a little bit neater. And then we're also going to collect the 2 positive rails. Now, as you can see, if I just delete this wire, for now, that whole positive rail is connected to each other. They're all nice and yellow. Because I've connected the 2 negative rails together, both negative rails are yellow, or ground rails. So we can do the same for the positive. I'm going to run that in, put a couple of bends in it to make it nice and neat, and I'm going to change that to red for positive. So now the next good practice is to ground your Arduino to that ground rail and also provide it with some kind of voltage. So if we get the ground pin, I'm going to go from one of the breadboard pins into the ground rail, and we're going to make that color black. And now what you should see is when I click my ground, you can see all of the ground pins light up, meaning that that ground is connected to the Arduino, enter the ground rails on the breadboard. I can do the same for the 5-volt line, so I'm going to take a wire from the pin here into one of the positive rail pins, and we're going to make that color red. And same again, if I click that, I get a whole red light up on every single positive pin there. So we want to light up our LED. So what we're going to do is, we've got a couple of options on how we could do this. So I'm just going to delete this wire if I can. We can either run it so that it is always powered on, or we could do it so that we could programmatically power it on using Flow or the Arduino IDE. So if we wanted the LED to always be on, we could just provide it with a 5-volt into the anode, and that way, whenever the 5-volt, the LED and the nano are powered up, that power would run from the 5-volt rail through the LED, up through the resistor, and then it will go into ground. So we have to complete that circuit by grounding that resistor using a black wire. So now the 5-volt output travels into the positive rail. It travels through this red wire into the the anode of the LED, running through the LED out the cathode, which connects through the resistor into our ground rail, which is grounded back to the Arduino. So we now have a complete or a closed circuit. The problem is, however, this would mean that our LED is always on. If we wanted to turn it on using the program, or say an input stimulus like maybe a light dependent resistor or something similar, maybe a motion sensor, instead of having the wire connected to the 5-volt rail, we're going to use one of our digital output pins. So I'm going to use pin 2. We'll connect from that rail into the leg of the LED, and I'm going to make this a yellow color. Usually for any kind of control, we make them different. So you want to try and make your colors of your wires something that you can understand and follow later on. So we can have control as yellow, we can have positive as red, we can have ground as black, and so on and so forth. Inputs could be one color, outputs could be another color. So now effectively, my LED will be off, and then when I tell the Arduino to turn pin 2 to high, it would send a 5-volt signal out, which would run through the anode, out through the cathode, across the resistor to ground, allowing our LED to turn on and off. So this is how we can make a basic wiring circuit in Fritzing.